Hello student, welcome into our second lesson. In our first lesson, we defined the center of gravity of a body, and also we discussed about determination of center of gravity of both regular and irregular shaped bodies. In this lesson, we are going to discuss the states of equilibrium. Then we will look at the condition for equilibrium. Finally, we look at applications of stability. First, let us discuss the states of equilibrium. States of equilibrium refers to state of balance of a body. There are three states of equilibrium. These are the stable equilibrium, the unstable equilibrium, and then the neutral equilibrium. Let's start by looking at stable equilibrium. And a body is said to be stable if it will return to its original position after being displaced slightly. So for example, if this funnel is pushed using this force here, after releasing the force, it will return back to its normal position. So at the end, it will return to this state. So it means that it is stable. The funnel will not topple over the line because the line of action, this is the line of action of weight, still falls inside the base. It is still inside the base, and the base is this one. So it is still inside the base of the funnel. Then we have unstable equilibrium, and the body is said to be in a stable equilibrium if it does not return to its original place when displaced by a small amount of force. Of course, we are saying small amount. So if you have a funnel standing like this one here, if a small force is applied at some point, let's say here, you realize that the funnel will not return to this position. Why? It is because the line of action, this line of action here, we are calling W, of weight falls outside the base of the funnel. So it is not inside here. It is not around this region. It is outside. Therefore, it is not stable. It is therefore unstable equilibrium. Then we have neutral equilibrium. And the body is said to be in neutral equilibrium if, on being displaced, the position of the center of gravity is neither lowered nor raised, like this one here. So even if I apply some force somewhere here, let's say here, this line of action will not change position over and over. So it will be in neutral equilibrium. Then we have conditions for equilibrium. A body will always balance if the following conditions are met. 1. The sum of forces on the body in one direction is equal to the sum of forces acting on the body in the opposite direction. The sum of clockwise moments about any point is equal to the sum of anticlockwise moments about the same point. This is the principle of moment. So it means that the principle of moment is one of the conditions for balancing of a body. Let us look at the factors affecting stability of the bodies. And one is the position of the center of gravity of the body. As we have seen, a body is more stable when its center of gravity is as low as possible. So it means this can be achieved by making the base very heavy. If the base is heavier, the center of gravity will automatically change. So it means that the center of gravity can change if the base is either made heavier or lighter. And bodies with higher centers of gravities are less stable. Base area of the body. Body is more stable when the base is wide. A narrow base makes the body to be less stable. So those are the two conditions or the factors which will affect the stability of the object. Examples of applications of stability. We have, these are some of the applications whereby the uses the two ideas here, that the factors which affect stability are the two of these ones. So the position of center of gravity and the base area of the object. And as we have seen, something can be done and then the stability can either be lowered or increased. One, we have the bases are made more stable by having lighter materials for the upper parts of the body, and then the heavier materials are put as low as possible, e.g. the engines. The engines are as low as possible. So this one will ensure that we have ensured that the center of gravity is very low. Then we have the racing cars. Example, the ones in Formula 1 cars have wider wheels and lower positions of center of gravity than ordinary cars. So they can be able to turn at a very acute angle without toppling or without falling or overturning. These are the racing cars. Then we have chairs, stools, tripods, etc. are provided with 3 or more legs. The legs are often made slightly inclined outwards to improve the stability, because we have said that the base area affects the stability. So the wider the base area, the more stable the chair, the stool, etc. will be. Then we have the Bunsen burner, has wide and very heavy base to increase stability. So you can be able to see that the base is very wide, and also the base is also made up of metals which are very heavy or are heavy. So it is very stable. Then a person carrying a bucket of water in one hand has to lean his body to the other side to adjust his position of center of gravity. This will ensure that the body is, or the person is, very stable, because as we have said, the position of center of gravity can change depending on whether you are adding the weight or you are reducing the weight of the object. And then we have a hydrometer. It's able to stay upright in a liquid because it is weighted at its base, and therefore its center of gravity is at the base. Then that marks the end of our lesson, and it is important that you go through the following assignments. And these assignments are very important because they will help us to understand this topic much better. And most of the answers are found in our notes. It is important so that you consult our notes, and they will help you a lot. Hopefully you will get the best out of this by going through these questions. And whenever you have any difficulties, we are always ready for you, student. So it's just upon you to talk to us, to consult us, and even your peers, so that we shape your tomorrow now. Until next time, let us meet in our third lesson.